Welcome, my followers, my students. I love you so much. What I want you to do is for you to click on that like button, share this page to your friends, to your loved ones. You can refer it if you like it. And I know that as you're in this class, you'll benefit more. Alright, today is our chemistry class, and we are going to talk on IUPAC nomenclature of compounds. IUPAC nomenclature of compounds. Alright, we'll start with the introduction. IUPAC nomenclature of compounds. This is the normal indoctrinated process of naming a compound. It is a process whereby we name a compound in the pattern that it is expected to be. Alright, now we don't have that power to do it, because there are some masters, or let's say some professors, that have already staged out some certain steps and some certain rules and laws that we are going to use so that we will achieve the naming of a compound through conventional process or through the normal process. Alright, we all, or some of us, may know the meaning of IUPAC. Let us talk about the meaning of IUPAC. IUPAC means International Standard, International Union rather, of pure and applied chemists. Now, this is a union that is meant for people that read pure and applied chemistry. Now, this union is existing for us to know the meaning of compounds, pure compounds, applied compounds. When you get to organic chemistry, we'll still see them active there in the naming of compound. They'll give us steps, they'll give us rules, so that while we do the naming of this compound, we will organize it in a standard that is acceptable worldwide. Alright, now before we name a compound, we need to note that I want to make it in a way that it will be very easy for you. There are 4 steps, 4 good steps of naming a compound. I have this capacity of shrinking it in a way that you understand it. 4 steps. First things first. The first step of naming a compound. Before you name a compound, you need to check whether that compound you are naming, is it a molecule or is it an ion? I mean, if it is a molecular compound or if it's an ionic compound. If, as I'm talking, you may be misunderstanding. What do you understand by ionic and molecular? They seem so confusing. Let me explain. Ionic means that compound has a metal and non-metal. Like we said, it has a metal and a non-metal. There is no two ways about it. And it is molecular if that element is a combination of non-metal. So now that means 2 non-metals bonding together. This one is the bonding between a metal and a non-metal. So that's the first thing we need to check. Whether it's a metal and a non-metal combination, or it's a non-metal combination. If it's a metal non-metal, it is ionic. If they are all non-metal, that means it is molecular. Alright. Molecular in the sense that it may also carry 9 hydrogen. If If you check when you have metals and non-metals, you don't see hydrogen. Hydrogen acts as a metal, hydrogen acts as a non-metal due to its character. Alright, so it may be containing hydrogen. If it's containing hydrogen, that means it's a molecular. Alright, now the next step we are going to talk about is the addition of IDE to the end of the second element. Addition of IDE to the second element. Now, what do I mean? Now we have calcium and fluorine. Are you following? Now, calcium is a metal, fluorine is a non-metal. Now it is ionic. Now, this is attached to the 2. Alright, it is ionic. Now what do is, we add IDE to the second element. That means it will now be calcium fluoride. Hope you are following. IDE to it. Alright, what if we have CaCl2? Now this is the same thing as calcium chloride. Hope you are following. Alright, the next step is to check if the compound is the ionic compound is what I mean by transition elements. There are elements that are transition metals. Example, chromium, vanadium, titanium, iron, cobalt, nickel, zinc, lead, them. So those are transition elements. Now check whether they are transition elements that have the capacity of displacing other elements. Do you know why these? Okay, no worry, I'll get back to this. Alright, let's see it in this format. We have FeCl. Now, this compound here is iron and chlorine. We know normally that the second law said that we should add IDE in the second element. So, for iron chloride, but that is not what we need. Now, we have iron has 1, chlorine has 1. Are we following? So what we do now is to write iron 1 chloride. Now in this place we have added a Roman numerals to it. Now this law states that the third step states that you need to check whether there is a Roman numerals to be added to the compound. The Roman numerals will be added to the compound if there is a transition element to it. Alright, now we have FeCl2. This iron chloride. But the 2, what does it stand for? Now, whenever you see these 2, know that it is going to come in the middle. We have iron 2 chloride. Note the transition elements. Remember, I told you the transition element as scandium, vanadium, titanium, chromium, argentium. We have copper, zinc, cobalt, lead, and iron. They are almost 30. First transition element, second transition element, third transition element. So I just named 10. Alright, so if those elements has the capacity of displacing an ion out. Now you need to take that ion as a Roman numerals and place it in the naming of that compound. Alright, the last step that we are going to engage on, remember I told you is first step. The first step is knowing whether it is ionic or is molecular. Ionic if it's a metal and non-metal, and is molecular if it's a reaction between non-metals. The next one is to add IDE to the second element in that compound. The third one is to check whether the transition element displays an ion which we will use as a Roman numerals in the compound. Now the fourth element which is the last one. Now this step says we should check if their ions are completed. All right, we have AOH. Now this one is 2 molecules of sodium hydroxide. Now sodium hydroxide. Now it should have been disodium. We can't do that because their ions are completed. The ions are completed. Sodium is 1, oxygen is 1, hydrogen is 1. Now if one assuming that nitrogen has 2, now we have 1 out. Hope we are following. Now we have 1 out. That is the reason why we have CO. This is carbon monoxide. Now carbon has 4 elements existing electron at the atom shell, while oxygen has 2 existing in this atom shell. Now it is going to share. That's the reason why carbon monoxide and this one CO2 is carbon dioxide. Alright, now we have ion 2 tetraoxide. Okay, let's see. Fe2O3. Alright, you have ion 2 tetraoxide. The last law says that we should check if their electrons are complete. That means the ions they give out are complete. If it is complete, then we should note that there is no prefix or suffix to add. There is no prefix rather to add. Now this one is ion 2 tetraoxide. Now ion gives 3 electrons, oxygen gives 2 electrons out. Therefore they have shared it and they are complete. There is no added, let me say 4 or 2. No, there is no added ion to complete the compound. Since there is no added ion to complete a compound, if there is no need of adding, what we have is ion 2 tetraoxide. But in a scenario where we have this particular element, let me say to be dinitrogen pentoxide. Dinitrogen pentoxide. All right, why is it dinitrogen pentoxide? Why is it not nitrogen pentoxide? Since now this thing means that oxygen has 2 to give, but at this point it has 5 added to it. Now the 5 there will be pronounced. Remember, we know that we need to bring the 5 out. Now, this dinitrogen is for this. The nitrogen. We cannot say mono in this. Okay, we have this to be iron 2 tetraoxide because diferrous tetraoxide. We can still put it diferrous tetraoxide, but we don't. The reason why we don't use ferrous. Ferrous is the Italian name of iron. We don't use ferrous in naming iron. We call it iron on its own. That's why we call it iron 2 tetraoxide. There is no need that iron there. That's that iron is not a standard in naming a compound. You need to name a compound with a standard. Now we name it due to nitrogen past 5 while oxygen past 2. Now nitrogen past 5 and oxygen past 2. In that process, we know that 2 has already been taken by oxygen. Now 2 can be represented by oxygen. We have 1 to be mono, and 2 to be di, 3 to be tri, 4 to be tetra. That's why we have tetra oxosulfate-6, we have some other triiosocarbonate 4 we have there. So this one is the nitrogen pentoxide. Why is this dinitrogen present? That is what my concern is. This dinitrogen is present because the nitrogen has 2. The nitrogen has 2. That's why I have the nitrogen. When we have CO, we cannot produce. We cannot say monocarbon monoxide. No, we just say carbon monoxide because this carbon cannot have mono. There is no need of putting mono in the first element. The only first element should be from 2 upwards. That's why I have trioxocarbonate. Now tetraoxosulfate we have from 2 upwards. The 1 is not mentioned. Now we need to make sure that we know when to add our prefixes, when to have our suffixes IDE, to know whether it is an ionic compound or it is a molecular compound. That is the first steps of naming a compound. Let us go into state of mind.